Last section of chapter 2, 2.4. They were going to be writing lines, talking about parallel and coinciding lines. Before we do that, we have to remember some stuff from Algebra 1. Two forms of a line, slope-intercept form and point-slope form. Slope-intercept form of a line is y equals mx plus b, where m is our slope and b is our y-intercept at 0, comma b. Point-slope form is exactly what it says it is. It has a slope and a point. So x1, comma y1 is your point. So the first problem says, write the equation of the line with y-intercept at 0, 1 and passing through 2, 7 in slope-intercept form. Slope-intercept form, we need a slope and intercept. We already have the y-intercept right there. So all we got to do is find the slope. Using our slope formula from last section, y minus y over x minus x. And reducing, we get 3. So our answer is y equals mx plus b. Y equals 3x plus 1. So this is a lot of practice here. Write the equation of each line in point-slope form and convert to slope-intercept form. So we're going to do all 6 of these, starting with point-slope and converting to slope-intercept. So for all 6, we need a point and a slope. For the first one, we don't have a slope, so we need a slope. Y minus y over x minus x gets us 3/4. That is not reducible. Pick a point. It doesn't matter which one. I'm going to use 4, comma 2. So y minus the y coordinate equals slope x minus the x coordinate. That's point-slope form. Now to convert that to slope-intercept, we're going to distribute the 3/4. And then add 2 to both sides. And that's slope-intercept form. Number 2, we have everything we need already. We have a point and a slope. So we're going to go right into point-slope form. And that's it. Now to convert to slope-intercept, distribute the 1/2. And add 6. And there's our 2 equations of the same line. Go ahead and pause the video and try number 3. All right, hopefully you got a chance to do number 3. So again, we're using point slope. There's our answer for point slope. And then for slope intercept, we're going to distribute that 2 and add 1. Number 4, we have a line with x-intercept negative 5, 0, so that's negative 5, 0, and a y-intercept 3, so that's 0, 3. So again, we don't have a slope, so we need a slope here. Y minus y over x minus x gives us 3/5. All right, so again, we can pick either point that we want. I'm going to use the negative 5, comma 0. So it's y minus 0 equals 3/5 x minus negative 5. So that's y equals 3/5 times x plus 5. And that's our point slope. To get the slope intercept, just distribute the 3/5. And that's our slope intercept. Number 5, we have our point and our slope, so we're ready to go write the point slope form here. Y minus 0 equals negative 3/4 x minus 8. So that's just y equals negative 3/4 x minus 8. That's our point slope form. For slope intercept, just distribute the negative 3/4. And that's our slope intercept form. Last one is a little shortcut to it if you recognize what's happening here. 1, 7 and negative 6, 7. That's a special kind of line. If you don't recognize, we'll go talk about it at the end here. But we don't have a slope, so let's figure out what the slope is. It's 0. So hopefully now you recognize what kind of a line it is. If not, we can still just keep going with our point slope. And hopefully we know that 0 times anything is 0. So that's point slope. And slope intercept, just add the 7 over. There's slope intercept. So y equals 7 is a horizontal line with slope of 0. And if you recognize that right away, because both y coordinates are the same, you could just say, all right, well, that means y is 7, horizontal line. Okay, page 3, we're talking about lines again. They could be parallel, they could be perpendicular, they could be coinciding, or they could be none of those three and just be regular intersecting lines, but we're not talking about those right now. Parallel, perpendicular, or coinciding. We know what parallel and perpendicular are. Coinciding means they're exactly the same. They look different, their equations look different, but they're exactly the same. So before we do all that, let's remember how to graph lines. So number 7 is in slope-intercept form. The intercept is negative 2. And the slope is 1, which means up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1, until we have what our line looks like. Pause the video and try number 8 on your own. All right, number 8, we have an intercept of 3 and a slope of negative 1/3. So down 1, right 3, down 1, right 3, or up 1, left 3, up 1, left 3. And there's our line. Number 9 is in point slope. That's okay, that's no problem. Our point is just the opposite of this, comma the opposite of this. So that would be negative 1, comma 2. And our slope is just 1/4. So up 1, right 4, up 1, right 4, or down 1, left 4. And there's our line. Okay, the fourth slide here says determine whether lines are parallel, intersecting, or coinciding. You have to solve the equation for y before we can decide. So we are going to have to solve each equation for y. The first one, number 10, is already solved both equations for y, so this one's a nice and easy one. The first thing you want to do is look at the slopes. The slope of this one is 2, and the slope of this one is 2. So they're going to be either parallel, or they're going to be the same exact line. Then we look at the intercepts. The intercepts are different. Therefore, they are not the same exact line. They must be parallel. So number 11, the first equation is solved for y, and we have a slope of 1/3. The second equation is not solved for y, so we got to divide everything by negative 3. That would give us y equals positive x over 3 plus 4. That also has a slope of 1/3, so they're going to be parallel or coinciding. The intercepts are the same. Therefore, these are the same line. We call those coinciding. Number 12, these have different intercepts. I'm sorry, different slopes. First one is 5, second one is 1. since the slopes are different, these are definitely not parallel, and they're definitely not coinciding. So these are just regular intersecting lines. They might be perpendicular, they might not. If we look at the slopes, we actually know that they're not, but it doesn't matter. All we care about right now is that they're intersecting. All right, for the last one, we know that this slope is -2/5. We don't know the first slope, so we need to solve that for y by dividing everything by 5. And we get y equals -2/5 x minus 1, 5 over 5 being 1. This one also has a slope of -2/5, so they are either parallel or coinciding. We look at their intercepts, they're different, therefore these must be parallel. And that's it for chapter 2. If you have any questions, remember you can always ask during class or email.